Hello everyone, welcome to today's webinar event, Scraping the Surface, Scrape Surface Heat Exchangers, Positioning and Applications, where you will learn the best suited applications for our various models of scrape surface heat exchangers and how to know when you need a scrape surface heat exchanger for specifying your equipment. But before we get started, I would like to introduce myself. My name is Sydney Wagner, and I'm the Associate Product Manager for the Waukesha Cherry-Burrell brand for our scrape surface heat exchangers, and I'll be one of your technical hosts. I joined SPX FLOW a little under 4 years ago as part of a rotational engineering program, and I was able to do an engineering rotational program as an order engineer, an R&D engineer, an application engineer, and then I have found myself as an Associate Product Manager. I'm also here with Steve Bays, who will be my co-host.
Hey, Sydney, thanks for the introduction. I joined the company back in 1990. I've been roughly 34 years with the company. My initial role was in application engineering, learned a lot. And today I'm in the product sales specialist. So kind of an experienced field guy, troubleshooting, factory representative type person for you guys to call on.
Yeah, thank you for joining me today, Steve. Our goal overall is to make sure that this audience understands the play that scrapes have in fluid processing and why selecting this equipment is important. A few housekeeping notes is before we get started, as an audience member, you will not have access to audio or video capability, but please use the Q&A feature to submit any questions throughout the presentation, and we will answer as many as we can at the end. If we do not have time to answer them all, our contact information will be provided during the Q&A session during the last 10 minutes or so of the session. Steve, are you ready? Let's get started with the discussion on scraping the surface.
Let's do it.
At SPX FLOW, our purpose is to improve the world through innovation and sustainable solutions. We'll touch on how our portfolio of scrapes can help you in these areas as we move through the presentation. Now, let's move on to today's agenda. All right, so today we're going to be discussing scrape surface heat exchangers, including what they are, the function that they perform, and how they compare to other heat exchange technologies. To do this, we'll focus on heat exchanger product positioning, Waukesha Cherry-Burrell's product portfolio, and then some real-world examples from Steve on these applications. And then we'll close out with a few aftermarket support options. All right, Steve, are you ready to teach us a little bit about a scrape surface heat exchanger?
I'm ready. So what we're going to do here is we're going to launch a quick video. It's on our website, basically kind of showing you the functionality, some of the main components, as you can see on the right-hand side, which is a product tube, a shaft, and blade system. The blades and seals, these are more or less the wear items in the heat exchanger. What we'll show you is how this thing is working. So that you have a better idea. It's a little different than a plate or a tubular technology. So this is the product in green flowing through the heat exchanger. And then you'll see the media as well. And that could be various different types of media that are flowing and exchanging that energy there. So Sydney stopped the video, and I want to talk quickly about some of the various things, and we'll talk in more detail later, but we can heat things with this. We can cool. We can crystallize products, we can pasteurize, we can sterilize products, we can gelatinize products, we can freeze different ones, and we can do evaporations. Now, evaporation is not one of our core things, but we do have older applications out there that do use evaporation. So as we go through the video, we can then show you basically what's happening inside the unit. First of all, you have this annular space between the shaft and the tube where the product is, and then you have the jacket space. This is where your media is flowing. So as the shaft rotates, the blades are scraping, and when the shaft's in the center, that's a concentric design. We have another version called the eccentric design where we off-center the shaft from the tube center line and create a camming action of the blade at 6 o'clock and 12 o'clock positions. The third position is oval design. This is where we actually squash the tube, keep the shaft in the center line, and then all of the blades are camming at different rates, but it keeps the shaft in balance for some of those very viscous products. So this is the portion of the presentation where we'll talk about heat exchanger positioning. So we're going to compare three very popular heat exchangers, the plate heat exchanger, tubular, and scrape. Will progress from the right to the left. We'll talk about plate heat exchangers and the advantages and disadvantages. First being the advantages of a plate heat exchanger are a small footprint. A lot of space in plants is very valuable. So the plate heat exchanger, just by its design, will take up less floor space than your typical other types of heat exchangers. It also provides a great opportunity for heat transfer. And what I mean there is regeneration, heat recovery, which is very important for some of the ROI calculations for these customers. And it's a low additional cost of investment. The problem is that its low pressure capabilities compared to the rivals in this presentation. Usually about 250 is the maximum. Also, there's multiple contact points. So there's going to be either, you can either have no or fewer fibers because the plate would act like a big filter and eventually plug up, and then you'd have to disassemble it and clean it. Also, a lower range of product viscosity than the other classes. So you're into milks and juices and things like that. As we transition over to tubular, this is going to be one that has no moving parts. So it's got a low cost of ownership compared to, say, a scrape. But it also has the capabilities of heat recovery and regeneration. And then when we look at the footprint, though, that's going to be a very difficult footprint. In many cases, these get very, very large, 20, 30 feet long, and take up a whole processing room. So the spin from that is that you get a lot of holdup volume, you get potential waste, and how do you recover that? And that always becomes a factor as you decide which heat exchanger to select. Also, the viscosity range is somewhat limited. It's better than a plate heat exchanger. You get this low to what I call semi-viscous fluids. And then we transition over to the scrapes, and that is the highest viscosity products are done in these heat exchangers. It's typically more in the cooling side because that's where it gets so difficult. But there's so little volume inside each cylinder that there's very little waste, and that's a good thing for products that are very expensive. The beauty of this is the mixing. We don't talk about it. We don't tout it as one of the main objectives, but you get a more homogeneous product based on just the sheer rotation of the shaft and the product coursing through the unit. It does require regular maintenance, so that's not as attractive. But that's just kind of the nature of the beast, right? You have all these moving parts, so you have to pay close attention on the maintenance aspect of the equipment. It's higher initial capital cost too compared to the other two that we talked about earlier, and you have a direct power source that will have some power consumption versus the other two.
All right, so Steve just touched on a few different factors of how to decide what heat exchanger you might need, and that could be footprint, pressure, or if your fluid has fibers. But one that we'll focus on a little bit more is viscosity. So viscosity is a resistance to fluid flow. Something that has low viscosity could be considered water-like, whereas a room temperature peanut butter would be considered viscous. So what are some relationships that we want to consider with viscosity? Well, the first can be temperature. So in general, typically fluids, when heated, become less viscous than at cooler temperatures or even room temperature. An example of this could be a caramel that you have in your refrigerator. You may heat it up in order to make it easier to pour onto your favorite dessert. Other relationships, another one to focus on is shear or shear rates. Typically, fluids are thixotropic, which means that the viscosity decreases as shear increases. And then it can then rebuild its viscosity back up as shear decreases. This can be tomato-based products, cream cheese, lotions, shampoos. On the opposite end of the spectrum is something called a dilatant fluid, which the viscosity actually builds up and increases as you increase shear rate. And this is just important to know because you don't want your pressure loss across a product tube or a pipe to increase as you're adding more and more shear You just need to understand how that fluid is going to react. And then lastly, you could have a Newtonian fluid, which an example is water. This is when the fluid is not really impacted by shear or shear rate, and it stays relatively constant, although it can still be impacted by temperature. All right, so why are we talking about viscosity when we're supposed to be talking about heat exchanger positioning? Well, now we're going to show you. So this chart can be an example of if you were going to plot your product's viscosity. So on the y-axis, we have our apparent viscosity, which could also be called your dynamic viscosity. So it's again your processing viscosity when the fluid's being at the same temperature that's going through your system at, or it's being sheared. And then on the x-axis, we have our shear rate, which is what we just talked about with all those different types of relationships. And then on the chart, what I want us to pay attention to is that we have different colored zones for which heat exchanger would be most appropriate or sufficient for an application that would be in that zone. So on the bottom of the plot, you can see the light gray section, which is the APV plate heat exchanger. This is going to be for your smaller particulate size, lower viscosities, lower pressures. The green section is our new Votator Origin, which again was launched at the beginning of this year. It's our light duty scrape surface heat exchanger. So it's the right selection for lighter duty applications, but where you still need some type of scraping mechanism against the wall. So if you have any, freezing or product buildup, you want to scrape so that you still have that homogeneous mixture in your heat exchanger. And then lastly, the Votator II. This limitation between the Origin and the Votator II, the Origin's rated up to 15,000 centipoise at that shear rate and viscosity of your processing system. So above that, we recommend the Votator II for those other applications. Okay, so then in addition to those three technologies, plates, and then the lower and higher duty applications for scrape surface heat exchangers, we also have the tubular technologies, which Steve previously brought up. So here is actually where there's some overlap between a plate heat exchanger and a scrape surface heat exchanger. So we have this dashed box for the tubular technologies. So at that point, it's not just viscosity that you should be considering when selecting the right heat exchanger. There's some of those other factors at the beginning that we talked about. Otherwise, an application engineer can definitely help us make that right selection. So now let's look at some product application examples. First, we're going to start with cream cheese. And not every user or engineer will even know what their fluid's viscosity is. So if that's the case, there are testing equipment out there that's available. There's something called a rheometer or a viscometer, and both of these can take viscosity measurements and build a plot like this relative to shear rate and temperature. We actually have this in our Delavan, Wisconsin facility. So if you have an application that needs to get tested, there's a chance that we'll be able to do that testing for you. So again, this is cream cheese. It's just an example. The viscosity could be different depending on what the recipe is of that cream cheese. So again, just for reference only. But I want all of us to take a look at that solid line, which is cream cheese at room temperature or 70 degrees Fahrenheit. And then when the cream cheese is at a warmer temperature, say 180 degrees Fahrenheit, you can see that the viscosity drops in comparison to cooler temperatures. And without looking at a specific process, a quick check that I like to do is looking between the shear rates of 10 and 100 per second. This is pretty typical for a processing system. So it's a good quick check just to see what heat exchanger might be appropriate for the application. But as you can see, when cream cheese is cooler, a Votator II might be required because you can see that lighter green at the top of the screen with that solid line. And then at different warmer temperatures, a Votator Origin could be just as sufficient and a little bit more cost effective. Steve, I think previously you mentioned to me that you've had customers with cream cheese try to decide between a Votator II or an Origin. Can you talk a little bit more about that?
Yes. A lot of customers, when they're batching, they have to bring this cream cheese up to temperature and then cool it. And that's where the Origin comes into play because of the viscosity range on that hotter, warmer side. It's the most effective and most cost effective as far as that goes. And then because the origin cannot handle refrigeration, then the customer has the Votator II to go ahead and cool it down even further, even to 70 if need be. So that heavy duty, robust design is much better for that cream cheese. As it really gets cold, it gets viscous. So yes, that's kind of like a scrape hybrid system.
So just to confirm, you have seen a customer use both a Votator II and an Origin or a light duty heat exchanger in the same facility, same system, just for different portions of the process.
You bet.
And then a lighter duty application could be ketchup or a tomato-based product. And here you can see, depending on where you are, shear rate wise and even temperature, the Votator Origin could be necessary. It could be a little bit thicker, more viscous than you'd want to use in a plate. But again, when it's heated, if it's sheared at a higher rate, a plate could be definitely appropriate. And like Steve explained with cream cheese, there might be an application where in the cooler portion of the process, you could use a scrape surface heat exchanger, and then in a warmer portion of the process, you could use a plate heat exchanger. Just selecting whatever is best for that portion of the process. You're not necessarily locked into one technology for that food or industrial product. All right, I'm going to hand off to Steve to touch a little bit more on some of the types of processes that you could see.
Yeah, so we have a lot of different process ranges. You're typically talking with customers, and heating and cooling can be done in all three of those types of heat exchangers that we mentioned. But as we get into phase change, such as crystallization, there's a lot going on there, and the product is changing. And so if you have crystal formation, things like that, you may see that would plate out on a tubular type of technology or even a plate. So that constant removal of product from the tube wall, especially at these very, very cold temperatures that are typically used in the crystallization type products, we're using freons and ammonias at 0 degree Fahrenheit. So it becomes a very cold surface, and you can't really remove anything in a plate or tubular technology. So that's one process that's very popular in fats and oils arena, and some in peanut butter. Pasteurization, the most common is plate and tubular technology. And the reason is tubular and plate have that capability of regeneration or heat recovery. And there's a lot of 3-section processes within those two technologies. Sterilization is one that is very popular with the scrape surface heat exchanger. Some people refer to that as aseptic, and that is where you basically have killed everything and it's a sterile product. In that, you're taking temperatures up to 290 degrees. So this is where you definitely want the Votator design. Also, another type of process is what we call gelatinization. That's where we may take a water and starch, blend it, and then begin to heat it. And somewhere between 140 degrees Fahrenheit and 200 is when that process occurs of the hydration of water and starch together. And again, this is another area where we could maybe use dual technologies because of that. As you're hydrating the starch, it's relatively low viscosity. It's only when you're trying to cool it after the full hydration has taken place, you may need a scrape technology to get back down to the packing temperatures. And then we have slush freezing, and we do that in a scrape surface heat exchanger, especially for orange juice concentrates that have a depressed freeze point where we can actually cool the product further and then actually create some slush, not ice, but ice crystal formation. So these are all the process range you would typically see from a customer. Again, heating and cooling are the primary, but there could be some other categories that we have to fulfill. And that may affect the exact type of heat exchanger or in a particular class there, which heat exchanger might work best. Earlier in the presentation, when we watched the video, we saw the different versions that we offer. with our scrape surface technology. The first one is concentric, and this is primarily the selection that we use. It will handle that, what we call the medium viscosity range. It would be part of that heating, cooling, crystallizing section of products, where we could still consider it a low power requirement. And that's available in all of our technology, whether it be the standard Votator II or the extra heavy duty version, or even the Origin. As we transition into the medium to high viscosity range products, and this is always our primarily cooling applications, especially in products like peanut butter, very sticky, that want to adhere to the shaft during that cooling process, then we would want that to keep that shaft clean and in balance at the RPMs that we're running. And that's only available in the Votator II and heavy duty Votator II. And then lastly is the oval design. And this is when we really transition into high viscosity products. They're always typically cooling products with high torque and high horsepower requirements, where we may be 30 horsepower motor. Products like marshmallow is a common one. Another one is building caulk. So these are the applications that are typically also in the heavy duty, extra heavy duty configurations, where we do things differently with our bearings and our shafts in order to handle that kind of power that would be needed to cool the product through its desired range. So again, why do we choose the Votator II? And as you can see, there's a lot of components in the illustration, and we can talk about those. But really, why would you need it? You're looking for consistent, reliable heat transfer performance. With that constant scraping action, you're going to remove the product consistently from the wall, therefore renewing new product as it's flowing through the heat exchanger. And that's really important. You don't have that stagnant flow that you may have for a lot of these viscous products in a plate or tubular technology. The other thing that's we have such a broad range of applications that we're capable of addressing with the scrape surface heat exchanger, whereas when you get into plate and tubular technology, that range narrows quite a bit. So we can not only do a lot of the sanitary products, but we can get into the personal care and the industrial product as well. And so this is very adaptable. I'd say that's a very good term, maybe adaptable to so many different applications and so many different processes that we talked about earlier. So it would be replacing, say, slow and inefficient type of batching operations. That's another thing that, we like to think that this is a heat exchanger that just loves continuous processing and flow. It will keep working consistently and give you really a uniform product, homogeneous, and a repeatable solution, whereas you might struggle with that in other type of technologies. One of the things we did recently is we upgraded our Votator II vertical lift system. Our original system was designed and released in 1999. And as we got field feedback from the customers and service techs over many, many years, we felt like it was that time that we needed to think differently. Also, what kind of drove us into this was the 6x84 was launched back in the around 2012-ish range. And there was other reasons why we launched that, but this was giving us a leap from 9 square feet in the 72-inch unit to 11 square feet in the 84. But that requires more height. The shaft extraction on an 84 is more than 72. So that was addressing those issues as well. And then, of course, the weight of the 84 was going to be a little bit more than the 72. So we upgraded the hydraulics package so that we could handle that extra weight. But we wanted more flexibility. What this does for us is not just a single shaft lift and drop, or drop and lift. this would allow us to do two shafts simultaneously, and we felt that was a kind of a market requirement with especially in the meat industry, this is really where we targeted this, is because of the daily tear down. And this would give us that flexibility of dropping both shafts, doing any kind of repair, maintenance, and inspection by the USDA and even the internal folks there, and then quickly get this back in operation. So, there was a lot of things here. We also really wanted to kind of look at the ergonomics of it and making sure that we had a really good, stable system. And we also wanted the ability to then retrofit to existing. So, when we introduced this, we had kits developed, and it's in the e-sales platform. So our distributors could have access to those retrofits, and those could be completed by the customer. We have the instructions set up for that, or they could have our field service people do that for them.
Steve, for a new application, how does a customer typically decide between a vertical orientation like this and a horizontal orientation like we saw on the prior slide?
Well, sometimes that has more to do with floor space really than anything. Floor space is a premium in plants today. And so this really gives them the opportunity to go vertical and really save a lot of floor space. The counter side of that is that, some people just have plenty of floor space and it doesn't really matter to them. But that's primarily the reasoning is that. And again, knowing that's important, this whole enhancement process for the lift seemed to make a lot of sense.
Okay, awesome.
The Origin is a product we have enhanced, and we launched it out. And I did some tech talks earlier this year to kind of introduce this to you. It's the lower viscosity range, up to 15,000 centipoise. We also wanted to make sure that we had that horizontal and vertical. Obviously, it's a little different because the Origin isn't going to have the hydraulic package that I mentioned earlier, like the Votator II, but rather it's a vertical orientation where we actually work off of a pivot point so that we can operate in the vertical mode, but we can service in the horizontal. So it's very manual, and it's simple, because of the pivot point, it's simple to do ergonomically. But we wanted that capability for these tight locations and plants. It does have, relatively quick and easy maintenance. We did introduce some new technology from the WCB side, and we incorporated a shaft and blade system. And we've done all of the testing internally to make sure that we get the good heat transfer performance. We have both a single and double mechanical seals because some of these processes simply need to have that. And it's supported by our field service people as well. So I think the one thing that's really unique about this product is not only is it global, but we've customized it and can configure it with the tools that Sydney, you were involved in as well. So it makes it easy for our channel partners to actually go in and actually utilize that tool, especially in the pre-phases of a project.
So Steve touched on now a little bit more focus on Votator II versus Votator Origin. And prior to that, we talked about, scrape surface heat exchanger versus tubular and plates. So let's say for a moment that we've already decided we need a scrape surface heat exchanger for our application. What are some questions you would ask in order to determine if you're going to be in a Votator II or an Origin? So of course there are many, but three basic ones that I would start with are: first, is your viscosity over 15,000 centipoise? So we talked about this a few different times. If the answer is yes, then we would start looking at the Votator II right away, as that's the limiting viscosity for the Votator Origin. But let's say it isn't. It's 10,000 centipoise, or it's in a, depending on the shear rate and the temperature, it's just less than the 15,000 limit. The next question I would ask is what media fluid is available. So some facilities may already have a media fluid that they're using for other processes in the same facility, or maybe this technology is replacing an existing technology. So if the facility already knows that they're going to use refrigerants, well, this is another restriction of the Votator origin. So we're going to need our more robust design with our Votator 2, which, as Steve mentioned before, customers use Freon or ammonia. But if you're considering using steam or hot or cold water, a glycol or brine, then we can still consider either unit for that application. And then lastly, the third question I would ask is what type of like tube design or configuration is needed? And this is that concentric, eccentric, or oval. So again, if it's the more viscous or really sticky application, such as like a peanut butter, then it's going to need an eccentric or oval design where you would lead yourself to selecting the Votator 2. Otherwise, if it's concentric, I would start with the origin because it's going to be the most cost-effective solution. But again, there's other things to consider, but an application engineer can help. And that might be, what's the percent fat crystallization? But I think these three questions are a really nice way to start between distinguishing which heat exchanger you need. All right, now I'm going to hand it back to Steve to go through a lot of real-world applications that we've seen with these heat exchangers.
This is probably my favorite area. I really get to share a lot about what I see in the field and have experienced over my career. The first one we'll talk about is cream cheese. This particular customer has a pre-cooler involved as well as ammonia, and they've broken it down into various stages. So you can see here from 77C to 56 with -1C ammonia. Then they get into pre-cooler section 2, where they take it down a step further to 39C with a -12C ammonia, and then in a final cooler. And they just keep bringing it down in stages. And this was a Votator 2 because it's refrigeration, and it was a 6x84 with 4 concentric cylinders. And what's unique about this, I guess, is the 5¼ inch diameter shaft. We haven't really talked a lot about the details of all the different configuration types, but this particular customer was looking for a real creaminess to the product, and the 5¼ inch shaft provided that. With the 350 RPM, we provided a very nice consistency of product. We used a chrome nickel tube for the highest heat transfer values, stainless steel scrapers as well, because as you go through this, you can easily freeze product up inside the unit when you use ammonia. So that's why we would use a metal blade. The silicon carbide faces were excellent because cream cheese does have some fat in there. So there is some lubricity associated with it. And of course, a 15 horsepower with FKM elastomers and refrigeration circuits. We didn't really talk a lot about that, but we do provide the drums and the ammonia Freon type valves around the Votator as well, if that's needed. Another one is flavored syrups. This was specifically an origin where we had about 14 cylinders and a lot of flavors, different flavors, and this was heating it from 65C to 99C, and this was using steam. And then in the secondary side of it, from 99C down to 37.8C with chilled water. This happened to be a duplex because of some of the syrup types. There was some concerns with the pH. We used a 4-inch diameter shaft with a peak Teflon configuration type blade. This was, as you can imagine, it's a very sticky product. So we used a double mechanical seals in a silicon carbide configuration. And this was a 4 horsepower at 339 with FKM elastomers. So this customer has been running for several years. I think we sold this in the about 2016 or so. And they're now coming back and looking at the second system with us.
Yeah, it's kind of fun to think about a product like that I put in my coffee every day is being processed by, one of our scrape surface heat exchangers.
Yep. One of the more core competency products that we have is when we take a vegetable oil. It could be soy or cotton seed or rapeseed. It could be palm oil. And this is that crystallization thing we talked about earlier in one of the processes. And this is where we take an oil and we're cooling it down rapidly, and we're what we call plasticizing, and creating going from a liquid you see on the left there to a more of a a crystallized type product. And this has been something we've been doing since the 1930s. So it's pretty easy for us to do. The tricky part comes in to the rate of crystallization on some of the oils, and some of the temperature profiles. But typically, we would use the chrome nickel tube for the highest heat transfer values. But because it's an oil and there's no water in this process, we can use a chrome plated carbon steel tube as an option, and it's a lower cost solution. And we often have our application engineers, quote this option because it is a lower cost option for us and the customer, especially if you get into multi-barrels, and you can save quite a bit of money for that. We also typically will use the 4.5-inch diameter shaft. And something you see on here is we use a shaft water heater. So we're able to circulate warm water along the length of the shaft in order to keep that shaft just slightly above the melt point of the shortening product. And that will help keep that shaft that's turning at about 360 RPMs in balance. Remember, we talked about crystallization, and it can be very random. So it wants to build to the shaft. So that's why we would use that shaft water heater. Another element to the high lubricity products is silicon blades. This is a lower temperature blade, inexpensive, and it works great in high lubricity applications. So that again keeps that total price point down. Again, single mechanical seals, pretty simple because of no water activity in oils. We don't usually have water in the seal area. Ceramic carbon type configuration is typical. We use a 20 horsepower motor. You may say, well, that seems a little too much for the application, but anytime you're using ammonia to cool something, there's always the possibility of freezing the product solid inside the Votator. And because of that, we have the 20 horsepower to help assist with getting that out of a freeze up conditions. There's other strategies that we use and we talk to our customers about, such as hot gas, or we just have freeze protection, which is a self-monitoring system that will predict that the freeze up condition is occurring, and we can help mitigate that through a cycling of the valves in a certain way in order to keep it from doing that. Another one very popular, another core competency of ours is pet foods and mechanically deboned meat. This happens to be mechanically deboned meat, where we're cooling the product. Typically, it's from 12C roughly to 2C, and with ammonia. This is done in a 6x72 Votator. Sometimes it's an 84. This happened to be 2 concentric cylinders. We do them both in vertical and horizontal. It just, again, depends on the floor space in the plant for the customer. We typically do use the chrome plated nickel, though, because of that high heat transfer coefficients. And it usually helps us, keep the number of cylinders in the application down to a minimum. We use a 4-inch diameter shaft, lightweight, especially in the vertical mode, so that it's easier for the operators to bring outside the unit if they need to get it into the horizontal position to do any kind of work. Because there's some potential bone dust, bone chips in some of these types of products, we'll use a stainless steel blade, as well as, because it is a ammonia application, we have a tendency to, again, freeze up, and a plastic blade does not usually hold up as well in this particular application where we see ice inside the barrel. So that's another reason. The seals are chrome oxide. These are very robust one-piece seals that tend to hold up during all of the maintenance activities. And really, the key to this whole thing will be the 190 RPMs. This is the optimal condition for us to make sure that we complete the heat transfer, but we don't add too much mechanical energy back into the product based on the motor horsepower. Peanut butter, again, a core competency of ours. We are pretty known globally for this, and we've made a lot of inroads into South America with this. We've had really good acceptance in the Latin America now. So we have quite a bit of business here, and we have some in South Africa and some other areas, but it's a protein that is common. again, standard peanut butter. This one happens to be 71C to 35 using a glycol solution. Now, this again goes back to that whole which configuration do we use? And because of the sticky nature, we want to go with an eccentric design. What we found out over the years, and we've done quite a bit of testing, some of this was learned in the field, but 230 RPMs, 245-ish area with a 20 horsepower gives us that optimal condition where we don't input too much additional mechanical energy, so we can maintain the integrity of the process that way. Again, we have to go to the 4-inch shaft because of the eccentricity. And in this particular case, we used a 17/7 blade, which is a little different blade, cutaway style. So it allows us to let product run through the heat exchanger, but around and through the blade. So we can keep our blade tip pressures inside the unit to a minimum as we go through that eccentricity and that pinch point in the system. Elastomers for the oils, silicon carbide is very standard. Now, when you get into some of the what we call low fat formulas, then we may have instances where we have to move into an oil design. But if most of your production is in standard full fat peanut butter, it's good to use an eccentric design. A grease is another big one that we've done quite a bit of work for some of the major petroleum companies. In this particular case here, it's cooling from 132C to 77. It's pretty warm, actually, using a chilled water as the cooling media. So again, this is a 72-inch concentric unit, chrome-plated nickel tube. This is an application where you could, in fact, use chrome-plated carbon steel because of no water activity. 4.5-inch diameter shaft, and some of these they'll use a shaft heater. Not everyone that is in this grease cooling industry uses the shaft heaters. Plastic blades, high lubricity. So again, getting back to some composite, whether it be Celcon blade. Well, it couldn't be in this case Celcon, but we'd have to go to a PEEK style blade there. And then single mechanical seals, 10 horsepower, 350 is a good optimal point, and FKM elastomers. And these are like jams and marmalades. This is a pretty typical origin application. Low viscosity, stainless steel tube, 2.5-inch diameter shaft. We do that because some of these have some particulates. And so we want to do that, and we'll typically turn these at a little bit lower RPMs, double mechanical seal. It kind of gets sticky in there. So we would want to flush those seals, similar to like the syrup application we talked about earlier. But 3 horsepower is typical FKM type elastomer. Again, the origin with this 2.5-inch diameter shaft gives us that space we need for some of those. Typically in your jams and marmalades, you don't have to worry about the integrity so much because it is a jam, right? So it's not as critical, say, a yogurt type product with fruit that you want to see the consumer wants to see the fruit. So we talked a little bit about this for a couple of applications, and I just wanted to kind of share with you quickly on the starch paste side where we are using like origin on the heating end. This is that low viscosity range where we're, hydrating the starch, gets building viscosity. We're up around that 200 mark where I talked about the starch and the water really get fully hydrated. But even so, at 200, it's going to be a lower viscosity, right? So there's not as much to worry about. And then you get into this phase called the hydration. You want to get a fully hydrated product. You want it to build its body and viscosity. So you may use a hydration tube, hold tube, some people will say, and they'll hold it and get that resting time, non-agitated, and they're trying to hold it to get that full hydration and body to the product. And then that's when it can start, as it comes down in temperature to 70 or even different temperatures, it can get pretty viscous. Again, it depends on the type of starch. There's all sorts of different types of starch, and they hydrate at different temperatures, and their viscosities can vary quite a bit. So these are products, this is what I call a starch paste base material that's typically used in the production of mayo, mayonnaise, other types of products like salad dressings. It can also be used in some of your lower end ketchup and cheese sauces as a substitute thickener for tomato paste in ketchup and real cheese and cheese sauces. So there is certainly, application for it within the various, types of products out there.
Okay, and then lastly, we're gonna close with some aftermarket support programs that we have available. So the first is our tube and shaft refurbishment programs. So we actually recondition used product tubes or shafts from customer facilities to extend the life. So instead of scrapping the existing equipment, we can refinish them if they meet all of our specifications so that they can be reused for that same application. We also, for our tube refurbishment program, offer a self-inspection option, which means that a customer can actually take these measurements at their own facility and send them to the SPX FLOW team, rather than shipping really heavy components back and forth without knowing if it qualifies for refinishing. So a little bit better for sustainability purposes. And then with that as well, we also monitor the data behind what tubes are being ordered and refinished and how frequently. And for that, we maintain a quick ship program. So with monitoring that data, we're able to select what tubes we have on the shelf so that customers have really fast turnaround times. And then Steve mentioned earlier, we have our new vertical lift system, and we've been selling these, the vertical configuration for years prior to this upgrade. So if at your own facility, or if you have a customer at a facility that has the older vertical lift and they want to upgrade to benefit from all the new design changes, we do offer the vertical lift as a kit. So it's just the hydraulics being upgraded there. We can have a service tech come out and do that for you. Otherwise, we have instructions, so someone on your own maintenance team could do that as well. And then a smaller upgrade that we did at the beginning of this year was a new shaft guard. So this redirects product if your seal leaks away from the gear motor, and it's a little bit better on the ergonomic side than the prior design. So again, this is what you would get if you ordered a Votator 2 today, but if you have a customer that finds the previous shaft guard challenging, you can get this upgrade right away. So with that, this ends today's presentation, and we will now begin our question and answer session. Just a quick note, after we complete the webinar, all participants will receive a copy of the presentation and a questionnaire. I encourage you to let us know if what you learned today is helpful so that we can better understand the value of our content. And please give me a moment while I pull up your questions. All right, first one, Steve, is that you guys mentioned a lot of food and beverage applications, but then we also mentioned grease. What other industrial or personal care products might require a scrape surface heat exchanger?
Well, that's a very good question. Most of the time, I believe some of our channel partners believe it. We just, deal with the food and sanitary type applications, but we have a long history of applications out in the market. A few of those would be like petroleum jelly. This is one where we would cool the product from roughly 140 to 90. And again, similar type configurations that I mentioned in the application section. Another one would be a plastic type product. I had a customer who wanted to take a liquid plastic and begin to cool it, and then they adapted a water jet at the exit of the Votator, and they would create pellets so that they could get these pellets to these blow molders out there that will make different types of products with that. Another one that we mentioned, or may have mentioned, wax. This is becoming more and more popular with the, with all of the different colors and container types, fragrances, and we do quite a bit of work in this area. We've recently had some good success in Mexico, where the customer was in a traditional tubular heat exchanger, and we were able to move them into the scrape technology, and it really changed the dynamics for them. It allowed them to run product more consistently, and allowed them to incorporate air, finely dispersed air in the wax. So we have a product note on that, I believe, Sydney, that we released to help our channel partners better understand that process and the benefits of something like that. Well, we've also done products like printing inks, mascara in the health and beauty area. Also products that would be used in sealing or coatings on roofs of buildings where they go in and coat the roofs and waterproof them mainly and get a good seal for those. So again, we offer a lot of different things, and we're pretty much open to anything that and it may be that we may reject it if it's outside of our comfort zone, but normally if we can get some pretty good viscosity data, a little bit of information on that, we will certainly have our application engineers review it and see if we can make that happen.
Yeah, I guess we also have rental units available, so if it's a new application, that's also an option. Another question that we have is, are Votator 2s CIP-able or clean in place, for those that don't know that acronym?
Yeah, this is a question. This is a good question because some folks use this more often than others. Some products just you aren't really CIPing, so to speak. But yes, we can. And a typical CIP flow rate in a Votator 2 would be around 100 GPM. You can usually use the same flow path as you would your product. Some customers like to reverse that flow path in order to loosen the debris a little more easily. I guess it would depend on the product and its characteristics, especially as it fouls the heat exchanger. Some folks will also pulse the CIP as well and create kind of some shock waves inside the Votator to help, again, loosen any kind of burnt product to the walls, things like that. The one critical element, I think, is not running the shafts during CIP for extended periods of time. I like to limit that to about 5 minutes per section of your CIP regimen. And then finally, there are some customers, depending on the severity of burn on and fouling, will run the shafts in a reverse direction. This is okay because it is what I call wiping versus scraping. So when you're wiping, the blade flops in the blade pin cradle, so to speak, and allows that blade to kind of help remove that debris. So we don't want to give the impression that we're an eco lab, okay? They will understand the materials of construction, and they understand the product, and so they would develop that. And I think the key elements will be being able to sequence that, whether it be a flush, caustic, final rinse, sanitation, but the other elements that are critical, and this is where they really come into play, is the chemical selection, the temperatures, the concentrations, and then the duration, and that's where they really shine. So we've gotten that question before, and typically we just don't want to get into their world, so to speak.
Okay, another one is, how is the material of the product tube selected?
Wow, that's another good question. This is something that always comes back to the application engineers, and it's not always evident. A lot of times it's based on whether one of the first decisions is the product acidic? Is the pH, in a acidic zone where it could be detrimental to a chrome plated tube, which typically we'd want to lead with a chrome plated nickel tube, because that'll give us the higher heat transfer values, fewer heat exchangers for the application, but it is susceptible to chrome flaking, and the chrome flaking is not a good thing when it happens in the field. So if they see something that's a little questionable, they may reach out on pH and see if we can get a better feel for that. And then secondarily, we would look at something like the CIP. What, for your particular cleaning regimen, would you have an acid component in there? That again could be. So there's two elements to it. It's the product and what its composition is, and then the CIP. Okay, so both of those working together would make that decision. You can go to a duplex material for some of those highly aggressive products that have that acidic nature to them. Let's say we're heating those and we want them in they're in a vinegar salt high temperature application. That's going to be the perfect environment for some sort of corrosion, pit corrosion, things like that. So you certainly want to address that with a duplex type material. So we have basically, leading from the top to the bottom, we have chrome plated nickel tubes, we have chrome plated carbon steel. We mentioned for some of those products like peanut butter that don't have water activity or shortening, those are perfect examples of a low cost solution path in the final proposal. And then we have stainless. We have stainless, bare stainless with plastic blades, or we have chrome plated stainless where we can use a metal blade. Let's say it's a frosting, a glaze, or an icing, something like that. We would then want to deal with that abrasiveness in there. And then finally the duplex, and we can also chrome plate the duplex as well. So we can use either plastic or metal blades.
Yeah, so that's a lot of information. So at any time that you or a customer is looking at ordering something through us, we have application engineers that can help you make that right selection. Okay, so we have a couple more questions, and a lot of them are focused on documentation and resources. So the first is asking if there's a manual. If you go to the Votator II webpage and you scroll all the way down, there's a document section where you can download a manual and other like brochures and flyers that have a lot of good information on it, like seal selection or blade selections. And then another question related to that, are there published success stories? There also are a few on that same page that you can download. But if you have a question about a specific application and a success story, or if there's a reference to like another, application out there that we've already had success with, you can send that to us through a district sales manager or a channel partner, and we'll do our best to give you information on a similar application so that you can learn about that from yours. Okay, so I think that's all the time we have. So I want to thank everyone for attending the session and for their time and their questions. So yeah, thank you again. Goodbye, everyone.